Hello students, let's see few more MCQs based on molecular orbital theory. Before going into the MCQs, let us see few of the tricks. How to find out the paramagnetism or the dimagnetism in a molecule and how to calculate the bond order by a shortcut method. So let us see first the magnetic property of any molecule. So always remember student, all odd electron species 10 electron species and 16 electron species, they will always be paramagnetic in nature, while all even electron species, they will be dimagnetic. Now let us see how to calculate the bond order by a simple bond order triangle. So this is the bond order triangle. If the electron total comes out to be 8 or 20, then the bond order will be 0. Similarly, if the electron total comes out to 9 or 19, the bond order will be 0.5. And as the electron increases in this way or decreases in this way, the bond order will increase by 0.5 or half. So when the total electron number will come to 14, they have the highest bond order, that is 3 according to the triangle. So by using this, let us solve the MCQs. See the first question, which one has non-integral bond order? So let's write all the 3 molecules first. Now let us calculate the total number of electrons. This will be 16 minus 1. So here there are 15 electrons. 16 plus 1, here there are 17 electrons, and 7 plus 8, here we have 15 electrons. So according to the bond order triangle, the first is 15, so it will have a bond order of 2.5. So here the bond order is 2.5. For 17 it is 1.5, and again for 15 it will be 2.5. So all the 3 options, they have non-integral bond order. So answer is all of these. Let's see the next question. Which one of the following species is dimagnetic in nature? Let's write all the 4 molecules first. After writing the molecules, let us calculate the number of electrons in each species. So here it will be 3 electrons. First student, this is He2. Being an inert gas, the molecule will not exist. But as the option is given, I am calculating the electrons. So here you will have 3 electrons, 2 electrons. This is H2 plus, so here you will have 1 electron and 3 electrons. Now the question is, which one of the following species is dimagnetic? So dimagnetic will be having even number of electrons. So the answer is H2, means answer is second option. Let's see the next question. Which of the following molecules or ions does not contain unpaired electrons? So let us write the molecules. Now let us calculate the number of electrons in each species. Here it will be 13 electrons, it is 16 electrons, 18 electrons and 10 electrons. Now if you see the rule what we have assigned, that all odd electrons, 10 electrons and 16 electron species, they will be paramagnetic, and therefore this is paramagnetic, this is also paramagnetic. And if you see this 13 electron here, so this is also paramagnetic. So the molecule which will have no unpaired electrons, means which is dimagnetic, is O2 2 minus, and therefore the answer is third option. Let's see the next question. Here they are asking, in which of the following ionization process the bond order has increased and the magnetic behavior also changed? So let us first write all the 4 options. Now let us calculate the number of electrons here. Here there are 15 electrons. Here it becomes 14. This will be 16 electrons, 15 electrons here, 14 electrons, 13 electrons, 12 electrons and 11 electrons. Now let us first calculate the bond order according to our bond order triangle. For 15 electrons, it will have a bond order of 2.5. So here the bond order is 2.5, which is now converted to 14 electron, that is 3. Here the bond order has increased. If you see this, for 16 the bond order is 2. Now the bond order has become 2.5. So in this option also students, bond order has increased. Let's see the next option. For 14 the bond order is 3, and for 13 the bond order is 2.5. So here the bond order has decreased. So this cannot be the option. If you see this for 12, bond order is 2. So first it was 2, now it is 11, means 1.5. So here also the bond order has decreased. So this is not the option. Now we have to select among the two. Now let us, if the bond order change is same, so let us focus on the magnetic property. If you see here student, this is 15 electrons and this is 14 electrons, means it has changed from paramagnetic to diamagnetic. If you see this, oxygen 16 means it is paramagnetic and 15 also remains paramagnetic. So here there is no change in the magnetic property, and so the answer is NO to NO plus, that is first option. Let's see the next question. Which of the following species exhibits the magnetic behavior? Let us write all the four options. So, and calculate the number of electrons here. Here it will be 15 electrons, 16 electron, 15 electrons and 18 electrons. Now they need to calculate the species that have diamagnetic in nature. Now according to our rules, this will be paramagnetic. This is an exception to even electrons. So this is also paramagnetic. This is paramagnetic. So this will be diamagnetic. So answer here is fourth option, that is D. The species which does not show paramagnetism is, let us first write the molecules. So, and let us calculate the number of electrons. So it will be 16, 15, 18 and 1 electron. So let us see, this is paramagnetic and paramagnetic because they are having odd electrons, and this is an exception, that is 16 electrons, and therefore the molecule which does not show paramagnetism is O2 2-. So answer here is third option. Let's see the next question. Which of the following has a bond order of 1/2? So let us write the molecules first. Now let us see the bond order triangle, but for such small molecules we can calculate. Here there are 2 electrons and therefore the electrons will go only in sigma 1s2, that is bonding. So it will be 2 minus 0 by 2. So the bond order here is 1. So let us come to O2 minus. If I calculate the number of electrons, it will be 17, and therefore the bond order here according to the triangle will be 1.5. So bond order here is 1.5. For nitrogen there are 14 electrons. So the bond order will be 3 according to the triangle. For this again the molecule has 4 electrons and therefore it will be sigma 1s2 and sigma star 1s2, means the bond order will be 2 minus 2 by 2, that is bond order will be 0. So which one is having a 1/2 bond order? That is O2 minus, that is second option. Students, I think you find this video useful, and if so, please do share with your friends. So don't forget to subscribe to my channel. Thank you students for watching.